Natural forces acting on all vehicles. Natural forces are found everywhere in the universe. These forces are acting on all objects or bodies, either stationary or moving, at all times. We cannot see these forces, but often we can see what they do. Let's see. What is a force? A force is a push or pull that can cause an object to increase its speed, accelerate, decrease its speed, decelerate, change its direction, change its shape. These natural forces are acting on all motor vehicles and affect their handling characteristics. These forces are balanced forces or unbalanced forces. Balanced forces. In general, if the driving force is the same as the counterforce of air resistance and friction, then vehicle that is already moving will carry on at a steady speed in a straight line. Vehicle that is not moving will stay stationary. Unbalanced forces. If the driving force is greater than the counterforces of air resistance and friction, then vehicle that is stationary will start moving. Vehicle that is already moving will speed up. It is important to know and understand these forces or laws, because if motorists break this or misjudge, they might have dire consequences. There are three basic ways that are used to control the motion of the vehicle. They are accelerator, braking, steering. Each of these functions is affected by the law of physics as gravity, the force that pulls vehicle towards the center of the earth. Driving force, the force which is generated from the engine of the vehicle to move the vehicle. Friction force, the resistance force between vehicle tires and the road. Air resistance, the resistance force acts on the front of the vehicle when it travels through the air. Kinetic energy, the energy vehicle possesses because of its motion. Potential energy, the energy vehicle possesses because of its position. Momentum, the force of the moving vehicle. Centrifugal force, the tendency of a vehicle to be pulled outward when rotating around a curve. Inertia, the tendency of vehicle to resist a change, including all objects or occupants in it. There are many other forces, but it is important to know these, their effect on the vehicle and the ways to control the vehicle in order to make safer and smarter driving decisions. When going uphill, the force of gravity will work against the vehicle. Motorists can accelerate or change to the lower gear to maintain their speed. When going downhill, the force of gravity will cause the vehicle to go faster. Motorists can use lower gears and sometimes apply the brakes smoothly to control the vehicle along with maintaining a safe speed. Friction helps the tires from sliding over the road surface. It increases the traction between the tires and the road surface. Motorists must slow down in slippery areas to maintain the friction and traction between the tires and road surface. The kinetic energy increases with the speed of the vehicle. Motorists can use the vehicle's brake system well in advance for the road situation to convert the kinetic energy of the vehicle into heat energy to stop the vehicle safely. When the vehicle is on the bridge or hill, it has the potential energy. Motorists may use the parking brake to maintain the energy. When the vehicle is moving, the vehicle and everything in it has the momentum. Motorists must apply brakes smoothly and shift to lower gears to dissipate this force. When turning through curves, the centrifugal force acts on the vehicle. Motorists may reduce the centrifugal tendency by slowing down the vehicle before beginning to drive into the curve. When sudden brake is applied, the inertia effect causes the vehicle and everything inside it to move forward. Motorists must use the seatbelts and secure everything inside the vehicle to make it slow and stop safely along with the vehicle. Natural forces on vehicles may vary depending on weight of the vehicle, height of the vehicle, speed of the vehicle, position of the vehicle. Forces involved in a crash. A fast-moving vehicle has a massive amount of kinetic and momentum force. Motorists can reduce these forces by smooth and gradual braking. If there is an accident that causes the vehicle to come to a sudden stop, The momentum force will have much more forceful impact and therefore more damage to the vehicle and more injuries to its occupants. However, if the vehicle slows down before hitting the object, or there is a longer time involved for the vehicle to come to a stopping point, the momentum force will have less forceful impact and therefore less damage to the vehicle or less injuries to the occupants. During an unavoidable crash, motorists may redirect their path toward objects that will cause the vehicle to stop over a greater distance, such as bushes instead of trees, sand instead of crash barrier, and avoid hitting a person, another vehicle, or solid immovable objects. Remember, always use vehicle safety features as they absorb energy during a crash and increase the distance over which the impact occurs.